Okay, question 3. Find dy dx for each of the following. So in part A, we've just got y equals 2. And I've drawn the graph of this just to make it clear to you to show why dy dx in this case is 0. Okay, so when you've got y equals to a constant, okay, as in this case is equal to 2, the derivative, dy dx, is equal to 0. And when you look at the graph of y equals 2, it's a flat, isn't it? Horizontal line. Okay, so y equals 2 goes through y equals 2, flat and horizontal. And if it's flat, if you think about it, the gradient's going to be 0, isn't it? It's got no slope. It is completely flat. Okay, so the gradient's 0 as such from that. Now when we look at something like that, y equals 7x then, right? Again, right, principle of graph work, okay? If we think about y equals x, the gradient of y equals x is just going to be 1, isn't it? Yeah, because if you think about it, when x is 1, y is 1, okay? And we can determine then the gradient there is 1, all right? Because the rise is 1, the step is 1, and 1 divided by 1 is 1, all right? So dy dx of y equals x will just equal 1. If you've got 7x, you just got to appreciate that x becomes 1, and then you've got a 7 in front of it, so it just becomes 7 times 1, which is 7. So dy dx is equal to 7, okay? And you've got a steeper gradient than you've got here, okay? So when y equals x, your gradient's 1, but when y equals 7x, your gradient's 7. It's much steeper, isn't it? Okay? You're rising quite quickly there. Part C, y equals 3x squared. So remember the rule now we use for differentiation. Okay, you bring the power down, 2, and times by what's in front, which is 13. So 2 times 13 is 26. X then, and you reduce that power by 1. So if you take away 1 from 2, you just get 1. So I'm not going to write it, you get 26x. Same rules apply then, different powers. You bring the 3 down, okay, the 3 down, times it by 4, you get 12. Okay, 12x goes squared. 3 times 4 is 12, and reduce that by 1 to get 2. Here, bring the 5 down, 5 times 8 is 40. And of course then reduce that by 1 so you get power 4. E, so here we've got a combination now of x to quite high powers and then single power, and of course then our constant. So when you differentiate this here, bring the 4 down, times by the 7, you get 28 x, and reduce that by 1 so you get 3, yeah, cubed. And then this just becomes plus 8, because the x, remember when you differentiate it, is 1. And then minus 2 just goes. It's 0, isn't it? Remember, it's a flat horizontal line going through y equals minus 2. So the gradient of that is 0, so it just vanishes. And you don't put plus 0, there's no need for that. This one here, now you'll notice here, dy dx, first term is straightforward, bring the 7 down, times it by the 2, which is 14, and then x, then of course the power 6, because you reduce that by 1. You can have negative powers as well, okay? With a negative power, it works exactly the same. So bring the minus 3 down. Minus 3 times 4 is minus 12. So we put minus 12 here. X then, and you reduce that power then by 1. So minus 3 then, if I take 1 away from it, you get minus 4. Okay, so it's exactly the same principle. Just be careful you've taken away properly there. Take away 1 from minus 3, you get minus 4. When you get this sort of question, right, 1 over x to the 5, you need to appreciate, before you differentiate, and you need to rewrite y, okay? And you need to appreciate that 1 over x to the power 5 simply means x to the power minus 5, right? You can think about like taking the x up, okay? But if you take it up, you then change the sign of that power. So it's positive 5, but if you take it up, it becomes x to the minus 5. You always got to do that. And then when you differentiate it, you bring the power down, so minus 5, x, and then you reduce 1 from there, yeah? So that becomes minus 6. And then finally here, with this one, you've got a fraction as a power, okay? So you've got a fraction of a power, bring the fraction down, 7 over 2. It doesn't matter if it's top heavy or improper as we call it, keep it as 7 over 2, x, and then you take away 1 from the 7 over 2. Now there's no harm in the exam, right? Just to make sure you get this right, put in your calculator, fraction 7 over 2, and take away 1, okay? Just to check, right? Of course it's 5 over 2, 2.5, but it's good to just check that there, right? And there's my power there. Keep it as a fraction, and we're done.